right, folks, this is our last topic, and there's going to be two assignments, one today, one Wednesday, and Wednesday's assignment's pretty short. I'm going to show you how exponential decay functions applies to buying cars, okay? But today we're just going to talk about exponential decay functions. Exponential decay and exponential growth are the exact same equation. Remember the equation? Y equals a times b to the x, where a is the y-intercept, right? That's where it crosses the y-axis, and b is the thing that's being multiplied. It's that multiply pattern, also called the base or the multiply pattern. Okay, x of course is just the I don't know, most of the time it's time, but it's your how many times are you doing this equation, okay? Which in real life cases, x is time. And a lot of times they even call it t, but it's not always time, it just depends. Okay? Now, there is one thing that's a little bit different. Exponential decay is, so we're going to go y equals, I'll just put a 1 there for a right now. This is a big idea right here. When it's decay, this value is between 0 and 1. Okay? So what I mean is this, and we're going to talk about that. I'm just going to put between here. Between 0 and 1. So it's less than 1, but it's greater than 0. Okay? And you're going to see what I mean here in just one second. Everything else that we were doing when it was exponential growth, this value right here was always greater than 1. Remember that we did 2, 3, we did like 1.5, 2.1. All those numbers were greater than 1. Okay? Now when it's exponential decay, the value is some sort of a fraction between 0 and 1. Okay? Let's get started. Most of the time, if we were in class together, I would start this equation as a fraction. You guys know that 0.5 is the same as 1/2. But because we're running low on time, I only have 2 lessons left. And you guys are going to see this again in Algebra 1, and I'll have a little bit more time to teach it to you. I'm going to do everything today with decimals. I'm going to stay away from my fractions. Okay? So, here we go. Watch. Check this out. I think it'll be a little bit easier to understand, a little bit. I don't know if it's easier to understand, but maybe less chance of making mistakes if we just deal in decimals, okay? So here we go. We're going to make an XY chart. You guys have seen this before. -3, -2, -1, 0, 1, 2, 3. All right? And you already know, where is it? Where are we at? Right here at the 0. Right? Well, that's that value right there, and that has not changed. So really, boom, simple. Okay. Now, Tanya, you got that phone?
Mm-hmm.
Okay. So, and you guys probably can see this, but so if we put a 1 here, all right. Now, remember, this is the thing that we multiplied by, right? So if Tanya takes 1 times 0.5, what is she going to get there?
0.5.
Right, so we have 0.5. So really so we're taking that 0.5 and we're going this way and multiplying it, right? So now, what if we go 0.5 times 0.5?
0.25.
Which is half, right? Half of 50 cents is 25 cents. Okay, and now what if we take 0.25 times 0.5?
0.125.
Okay, which is basically 12.5 cents. So all that should make sense. So we're multiplying by 0.5, right? Well, multiplying by 0.5, that's the same as multiplying by half, right? So if I said half of 4, well, that would be 2, right? Half of 2, well, that equals 1. Half of 1, well, that equals 0.5. Well, that's what we're doing right here. We're just multiplying everything by half. 0.5 is half. Okay. All right. Well, okay. Well, multiplying by half, what if we went backwards? So I'm going 1.25, and now I'm working this way. 0.25, 0.5. What am I actually doing here? If I'm working this way, Connie, can you see
Getting
it?
bigger
Getting bigger by how much?
by a half.
Getting bigger by, so 0.5, what would you predict would be right there?
1.5.
No, so what's happening here? I went from 12.5 cents to 25 cents, 25 cents to 50 cents, 50 cents to $1.
So $2.
$2. What did you do?
I multiplied 1 by 1.
Okay, so what's going to go right there?
4.
Okay, what are you doing?
I'm multiplying it by itself.
Okay, so what'd you go? What goes right
8.
there? So what are you doing? Every time, what are you doing in your head?
I don't know if I can explain it.
You're doubling it.
There we go. Thank you.
You're doubling it, right? So then remember this, that here we were multiplying by 2, right? Well, if you take, Tommy, do this on your calculator. Go 1 divided by 0.5.
2.
Okay, now go 2 divided by 0.5. Divided by 0.5.
4.
Okay, well, whoa, what in the world? How is dividing by 0.5 doubling it? Well, check this out. What we're really saying is we have 2 divided by 1/2, right? Okay, but everybody knows you never divide by a fraction, right? What do? We multiply by its reciprocal. So that is the same as 2 times 2 over 1. Well, what is 2 times 2?
4.
Divided by 1?
4.
4. Okay. So we're doubling it every time, but that's only when it's 1/2. Let's watch one more time. Let's watch and watch the pattern. So when we went this way, we were multiplying by 0.5. Now that seems a little bit weird. When you multiply by a number, it actually gets smaller. Yes, that's true when it's less than 1. Multiplying by 0.5. Multiplying by 0.5. Okay? So what happens when I'm going the other way? I'm not multiplying by 0.5 anymore. When I go backwards, what am I doing? I'm dividing by, so if I divided by 0.5, that's the same as multiplying by 2. Divide by 0.5, divide by 0.5, divide by 0.5. If you put in 1 divided by 0.5 on your calculator, so I work backwards, I'm dividing by 0.5, dividing by 0.5, dividing by 0.5. Okay, that's how I'm building my charts. Okay, now give me 1 second, I'll redraw this and we'll graph it. All right, while I had the video off and while I was kind of rearranging my whiteboard, Tawny said I was trying to describe what I was doing to you by adding. And she said I couldn't describe that. And it's a very good point, is that remember now when we are talking about exponential growth, we are talking about multiply situation here, right? So that is one of the reasons why linear is an add situation. But when we're talking about exponential, it's a multiply. So it's hard. It's a little bit harder in this case to say, okay, well, what am I multiplying by? Well, that's what you're multiplying by right there is 0.5. Okay. Now here's another thing that's interesting. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. Okay. And so we have -3, 8. There's one of our points. Okay. 2, -2, 4. 1, 2, 3, 4. Right about there. -1, 2. Right about there. It looks like this guy needs to be slid over just a little bit that way. 0, 1, which that's what we would expect. That's our y-intercept right there, right? 1.5. Right there. 2 is down to 1/4. 3 is down to 12.5 cents. Okay, here we go. I'm going to sketch, kind of use my dotted line here like this. And guess what? You never actually get to 0. You get really infinitely close to 0, but you never touch 0. Yikes. There's your graph. Now Now notice, what are some things that are the same? Well, this steep drop here is the same, right? Then things start leveling off. Wow, I'm struggling. Things start leveling off, okay? And so again, that's remember that exponential growth was where we had a steep line going this way, and then eventually it started going off into infinity like that, right? Well, now we're coming down in a steep fashion, and then we start to level off. Got something on the tip of my pen. That's so sad. Okay. Anyway, that's our first example. If that was a little rough, I'll show you a slightly different way. Next one example. As I've been doing this video, I've been wrestling with myself as to which one's easier, the fraction or the decimal. And then I think, man, a lot of times it just kind of depends. If we were in class, I would basically be teaching both and be kind of intermingling them. But I just wanted you to see this, that the equation that I'm going to be dealing with here is 3 times 1/3 raised to the x power. Okay, well, if you take 1 divided by 3, you're going to get 0.333333 repeating forever. So I'm going to leave it just like this, okay? But really what we're doing is we're dividing by 3. If you divide by 3, if you multiply by 0.33, the problem is when I multiply by 0.33, we're going to get some sort of decimal approximation here. So it's kind of a little bit rough knowing which one is exactly better, but we're going to go with this, okay? So what is something that's easy? This part right here is easy. You should know by now that whatever number is right there, that's what number goes right here, okay? So we're going to put a 3 right there, okay? Now, I'm trying to show you guys how I want you to do this on your assignment. I'm going to have Tani just multiply by 0.33, okay? So Tani, what is 3 times 0.33?
0.99.
Okay, 0.99 is really close to what? It's really close to 1, isn't it? So as you can see there, 3 divided by 3 is 1. Okay, so now what is 1 times 0.33? Okay. Remember, this is our multiplying pattern here, right? We're multiplying by 0.33. Now we're taking the 1, we're multiplying it by 0.33. What'd you get, Tony?
0.33.
Yeah, makes sense. 0.33. Okay, now we divide that, or we multiply that by 0.33, and what do we get?
One 0.1089.
1089. So we'll just go 0.1108. Yeah, 0.11, which would make sense. That was what dividing by 3 would do. So if you rounded it, if you take the rounding error out, then you're good. Okay. So now, Tani, when we're going this way, think about multiplying now.
Mm-hmm.
We're going from 0.11 to 0.33 to 1 to 3. What would be that number right there?
Would it be 6?
No, I'm multiplying by 3 every time.
9.
Okay, and then what's 9 times 3?
27.
Okay, and you might have to use your calculator. What's 27 times 3?
81.
81. Okay. So there, you can see our chart start now. You can see it's exponential decay, right? Dropping fast, then it starts to level off. We'll graph that in just 1 second.